Oracle backup and recovery concepts. In this nugget, we'll discuss the different types of failure that can occur on your database. I know it's an ugly reality, but all sorts of things can go wrong. For example, the hardware for your database might go bad, or perhaps you accidentally dropped a data file, or maybe an end user accidentally dropped a table that they needed. In order to plan for these disastrous events, we need to perform backups. And you also need to know how to treat these backups when something goes wrong, how to get back to the most current state. So in order to do that, we need to first of all configure our database for archive log mode. And then we'll talk about the different components that you need to back up. It's not only the data files that you need, but it's also things such as the archive logs, the password file, the control file, the networking configuration files, so you don't have to recreate those. And we'll talk about two different types of backups here. We've got full backups and incremental backups. Full backups are just that. We're backing up all of the data files. Whereas an incremental backup, we're backing up just the changes to the blocks since the last full backup. Oracle 10G came out with a new thing called block change tracking, where it keeps track inside of a file of all the blocks that have changed since the last incremental backup. So it just saves a lot of time when we're performing recovery. We'll also perform a hot backup and a cold backup. A hot backup means that you're backing up the database or a particular table space while the database is up and running, and it's completely seamless to the end user. They will never know that you're doing it. A cold backup is when you shut the database down and then you just go onto the OS level and you copy the data files. Let's review a condensed version of our Oracle engine. Now what we have up above here are three components of the SGA. We've got our log buffer, so whenever changes happen to your data, these changes are going to get tracked in the buffer, and then eventually when a checkpoint occurs, that will get written out to the redo logs by the log writer. We have our buffer cache, which contains database blocks, and server processes are either going to get its data either from the data files or from the buffer cache. It will actually try in the buffer cache first, and then if it can't find it, it will go into these data files and then load it into the cache. So the buffer cache eventually gets written out to the data files by the database writer. And then we have the shared pool, which is used for caching the SQL statements and PL/SQL blocks. We also have control files. These keep track of where your data files are, where your redo logs are, and it also keeps track of the SCN number, which is an indicator of the transactions. And so that SCN number is always getting updated in the control files, and it's also getting updated in the data file headers. So if you shut down your database and restart up and the SCN numbers aren't synchronized between your data files and your control files, you'll encounter a problem, and Oracle will let you know and you'll have to perform some recovery. If you're using passwords, you're also going to have a password file. Let's talk more about our redo logs because these are really important when it comes to recovery. Remember, these redo logs are written to in a circular fashion. If we only have two redo log groups, then this will get filled up here, and then it will go on to the next one, and then once this is filled up, then it writes to the next one, and so on. If you're in archive log mode, then the archive process is going to copy this redo log to an archive file, and these archive files are in numerical order. Both the redo logs and the archive log files are very important in performing recovery. For example, let's say we accidentally drop our user's data file. Well, we're not really going to notice any problems until we try to access an object in this data file or in the table space that this data file belongs to. Let's assume that you start up your database and you get this error saying that it can't find the users 01.dbf file. Well, what are you going to do? Hopefully you have a backup of that file, and then you're going to copy that backup to the location where it's supposed to be. Well, where do you find that location? You can dig in the data dictionary, and it should be pointed to by the control file. When you copy a backup to where it's supposed to be, that's called the restore process. It just means you're copying a data file. Well, let's assume that the last backup occurred 12 hours ago. Well, how are you going to get your data current? I mean, are you going to lose 12 hours of information? Well, hopefully not. What you do is after you restore the data file, then you're going to apply archive redo files. And that's what's known as recovery. Recovery is also known as rolling forward. So it's really, really important that we keep our archive log files safe and we keep our data file backup safe. There's a third step after this recovery process, and that's the rolling back of the things that were recovered. I know it sounds a little strange. Why would you recover and then roll back? Well, you're not rolling everything back. You're actually just rolling back the uncommitted transactions. Because remember, these redo log files contain all the changes made in the database, even the uncommitted transactions. In order for us to recover from data file loss, we do need to configure our database for archive log mode. When you initially set up your database with Database Creation Assistant, you have the option with a little checkbox, yes or no, do you want to configure it? Or you can configure it later after you create the database. There's a couple of ways to see whether or not your archiving is turned on. You can say select log mode from $database, or you can simply type in archive log list. I'm going to go ahead and do the select statement, select log mode from $database. And right now I'm in no archive log mode. Now in order to turn this on, we have to set a couple initialization parameters as well as bring the database into the mount mode and do an alter database statement, and then open up the database. Let's talk real quickly about some of these parameters that you will have set up. You must have a log archive dest parameter set. Okay, so we can have up to 10 destinations where your log archives are going to go. So these parameters are named log archive dest 1 through log archive dest 10. So when you specify the location, you can either say location equals and then the full path to where you want the archive logs to go, or you can say service equals and then you give the service name of the database that you want to ship it to. This would be used in a scenario if you've got a standby database that's taking in the logs of your primary database. So log archive format is going to have specifiers. This is going to be the way the archive log is going to look. It's going to start here with ARC, and the %S is the sequence number. Remember, all your archive logs have a number in there, and they increment by ones. The %R stands for the incarnation of the database. The incarnation simply means, okay, when you first set up your database, that's a first incarnation. If you have to reset the logs, it's going to be the second incarnation, and so on. The %T is going to be the thread number if you've got multiple threads doing these archive logs. If you want to dynamically enable or disable your log archive destinations, you can do that. So we have log archive dest state 1 through 10, and the value here is either going to be enable or disable. Log archive start equals, well, that value can either be true or false. This parameter actually was deprecated in 10G. This parameter just simply means yes or no. Is your database going to be archiving when you first start it up? You can also specify a max ceiling on the number of processes performing the archiving. And you can also tell the minimum number of archiving destinations in order for your database to succeed. If you don't meet this requirement, then your database will receive an error and you'll have to fix the archiving. And you can also set a parameter called log archive trace. By default, this is set to 0, which means we're not tracing any of the archiving activity. You can also set it to several values. The higher the number, the more tracing it's going to perform. So let's say that you are shipping your archive logs to another database somewhere and you're encountering some errors and you need to do some debugging. You might want to turn the tracing on here. I'm going to take a quick glance at my log parameters. The quickest way to look at all of them is just to say show parameter log archive. Quite a few things there. Let me maximize this window. And here we have our log archive dest 1 through 10. This log archive dest without a number after it is used in older versions of Oracle. It's just here for backwards compatibility. This log archive config is used mostly in Oracle Data Guard, so we won't cover that in this nugget. Down here we have our log archive dest state 1 through 10. And our archiving format is going to look like this. We've got our log archive max processes to be 2, so we'll have a maximum of 2 processes performing archiving at any given time. We must have at least one destination to succeed, otherwise we'll get an Oracle error. And our tracing is set to 0 here. Now I'd like to turn on my archiving, so what I'm going to do, and go ahead and do this with me, we'll do a shutdown immediate. So we shut down our database, and then we'll want to start up our database in mount mode. When we start it up in mount mode, what first of all happens, well, in the no mount mode, it opens up the processes and memory structures. And then when we get to the mount mode, it reads the control file. We have to have the control file open to modify our archiving log mode, so the control file is aware of that. But we can't have our database available to the general public. So let's go ahead and do a startup mount. And now we're in the mount mode. So at this point, we just need to do an alter database archive log. And our database has been altered. At this point, we can open up our database. Alter database, open. Now, it's making a modification to the control file, and it's also updating the data file headers. So at this point, what you would want to do is shut down immediate again and completely back up the whole database. I'll show you how to do that later. Let's check whether or not we have our archiving turned on. Select log mode from $database. And we are using archive log mode. Excellent. Let's revisit our location for our archive logs. If we just scroll up a little bit, you'll see that the log archive dest1 actually hasn't been set. We need to set this. So let's do an alter system, set log archive dest1 equals, and let's make this a location on our local file system. So we'll say location equals, and I'd like to put it in the Oracle product. You can put it anywhere on your system. I'll put it right here. 10.2.0 admin ORCL2 arc. And our system has been altered. So let's do a show parameter log archive dest1. Good, it's been set. One way that we can force a log switch is by saying alter system switch log file. So let's go ahead and switch the log file about 3 or 4 times. And now let's go to this directory up here and see whether our archive logs have been created. Okay, so let's go to our Oracle home. Okay. And then we can go to the admin ORCL2 arc directory. There are our archive log files. So we've got our sequence number, we've got our database incarnation number, and the thread number. So we've only got one thread writing these archive logs. We might have to use these archive logs to perform recovery if anything goes awry. I'll show you in a couple minutes how to back up data files. You can do that manually, or you can use a tool called RMAN, Recovery Manager. Other things you need to back up. You've got control files. Hopefully you have your control files multiplex. Hopefully you have 3 copies of that. But if you do not, then maybe you have a backup of this control file. Anytime you make modifications to your database, structural changes, you want to back up the control file. Well, if you don't have a backup of this control file, there is a way to create that, which I showed you earlier, and that is the alter database backup control file to trace. And this would generate a file with some SQL statements in there. You need to comment out some lines, but it basically gives you the syntax for recreating your control file. You also want to back up your SP file. The way we do that is we create our P file from SP file. Okay, so remember your SP file is a binary file, whereas the P file is an ASCII file. Anytime you make modifications to any of your initialization parameters, you want to back it up. You also want to back up your archive logs. You can do that easily with rman. You can also do that manually if you know which directory it's in. It's a good idea to back up the password file, but you're not completely out of luck if for some reason it gets deleted. All you have to do is get onto the operating system as either the Oracle user or someone who belongs to the DBA group, and you can issue the Oracle command called aura pwd, and there you pass in the file name that you want to call your password file, as well as the max number of users who will be logging on as a sysdba, and what the new password is for the sysdba. Backing up your networking files, such as your tnsnames.aura and your listener.aura, is also a good idea. You're not completely out of luck if you don't have these backed up, but if for some reason they become corrupted, you don't want to spend the time having to recreate them from scratch. And then it's also a good idea to back up your Oracle home directory and any of your homegrown scripts that you use on a regular basis. For this step, you can just go to the operating system prompt and use your copy command, or you can tar things up into a zip file or a tar file. And it might make sense if you're on Unix or Linux to create a cron job that backs these up on a regular basis. I'd like to focus on the different types of backups for our data files. We have hot backups and we've got cold backups. A hot backup means that you're backing up the data files either for a table space or for the whole database while the database is still up and running. The end users are not going to know that you're performing a hot backup. So this is great for a 24/7 environment where your company can't afford to have any downtime. When you say alter table space and then the table space name begin backup, what happens is that Oracle's going to perform a checkpoint to flush the stuff from memory to the data files. And then keep in mind that each data file has a header with the SCN number in there, and the control file has an SCN number as well. Well, it's going to freeze the SCN number of the corresponding data files. Now, the data files are still getting written to, so it's okay. Even though the database is up and running and we're about to back these up, Oracle has it all under control. So what you would do if you wanted to just do a hot backup of one table space, let's look at the users table space. Alter table space users, begin backup. Then you go to the OS level. You copy all the data files to a safe location on the operating system level. Then you get back to your SQL+ prompt and say alter table space users end backup. A nice new feature of 10G is that you can put the whole database in that backup stage. So you can say alter database, begin backup. Copy all of the data files on the OS level, and then you'll say alter database, end backup. Now, if you've got a really large database, I do not recommend performing this operation. And the reason for that is while the table space or the database is in that backup mode, Oracle's going to be generating more redo information than normal. Let's go ahead and do a hot backup for our users table space. Log in as the sysdba. And I want to first of all find out which data files belong to that table space. So we can say select file name from DBA data files, where table space name equals users. Okay, we've got one data file. So let's do an alter table space, users, begin backup. Okay, now those SCN numbers are frozen in the data file, and so now we can go to the operating system level and let's do a copy. And to make this fast, I can just grab this whole thing right here and copy it and then paste it. And let's go ahead and paste it just to the Oracle product 10.2.0 admin directory. We go back to our SQL Plus prompt and we alter table space, users, and backup to unfreeze the SCN numbers. To perform a cold backup, it's even simpler than doing the hot backup. You need to first of all find out which data files you need to back up. So you'll say select file name from DBA data files. Now in my system I've only got 5 data files. That's really small. On a large production database you might have a couple hundred. Well, it's rather tedious if you just copy them by hand. It's better if you create a script to do the copying for you. And you can actually create the script from some spooled SQL. For example, if I say select, and then in quotes, CP, and I append to that my file name, append to that the location of my destination, like this, from DBA data files, look at what we get. We might need to change the settings on here so the window is a little wider. Here we go, it's a little bit wider, and we can re-execute this. We might have to change the line width size, maybe make it a little larger. There we go. So see how we now have this into a copy command? And so then you can spool this. We can call this mycopy.bat, re-execute it so it goes into that file, and then do spool off. So then all you'd have to do is run that batch script. Make sure you get rid of the heading in the batch script. Some databases are so large that if you were to perform a full backup on it, it would take hours and hours, maybe 24 hours. To alleviate this pain, we have what we call incremental backups. An incremental backup is just backing up any of the database blocks that have changed since a particular time. There's actually 2 different types of incremental backups. The default type is called the differential backup. And so you see down here we have August 1st through the 8th. And on August 1st, we performed what we call a level 0 differential backup. That is essentially the same thing as a full backup. The only difference is that it's used as a baseline for an incremental backup. Okay, so on August 1st, we performed a level 0, which is backing up everything. And then on August 2nd, we can perform a differential backup, level 1 backup, and that simply means back up any of the database blocks since the day before when this level 0 occurred. Then on August 3rd, well, we've got yet again another level 1 backup. So it's going to back up the changes made since August 2nd and so on. So by definition, the differential backup is just backing up any changes made since the last level 0 or level 1 backup. Whereas the cumulative backup is going to back up any changes made since the last level 0 backup. So you'll see here that the further we get away from this level 0 backup, the longer it's going to take. You can implement these differential and cumulative incremental backups through our Recovery Manager tool, which we'll cover in another nugget. You might want to implement a backup strategy where once a month you do a full backup, like a level 0 incremental backup, and then weekly you perform a cumulative level 1 backup, and then daily you can do a differential backup. That way you'll never have to apply more than 1 day's worth of redo information if you have to perform recovery. A new feature that came about with 10G is something called block change tracking. Basically what happens during an incremental backup is Oracle's going to go through each and every database block to see if it needs to be backed up. Well, if you turn on block change tracking, then whenever a modification is made to a data file, that block is going to be flagged, and there's going to be a pointer to it in a special file. And then when you need to perform an incremental backup, that backup is going to be so much faster because we don't have to scan through each and every database block. This feature is not automatically enabled with your database out of the box. It's a special add-on But if you have this, then it's pretty easy to turn on. You simply say Alter, Database, Enable, Block Change Tracking, Using, File, and then whatever file name you want to have. I'll just say full path here. Make sure it's a valid directory path. If you want to see if it's turned on your database, you can simply say select star from $, block change tracking. Let's review what we've learned in this nugget. The first thing we talked about are the different types of failure that you can encounter. For example, you might have media failure if a hard drive goes bad. You might have a user who drops a table or some kind of object and they need to get it back. Control files can become corrupted or they might disappear. Maybe you accidentally deleted them. You have password files, you've got parameter files, you've got archive log files. All of those can disappear or become corrupted, so we do need to make sure we back those up. Then I showed you how to configure your archive log mode. Remember how you shut down your database completely, then start up in the mount mode, then do an alter database archive log, and then open up your database. Make sure that you also set the parameters that we discussed so it has a destination to place those archive logs into. We talked about the various components to back up and the different ways of backing up data files. For example, the full backup is where you're copying all of the data files, whereas the incremental is only backing up changes since the last incremental or the last full, depending on whether it's differential or cumulative. And then the new feature in 10G was block change tracking, which tracks change data blocks in a special file, and it just makes your incremental backups occur much faster. And then we talked about the difference between hot versus cold backups. For example, the hot backup, you're just freezing the SCN numbers in the data files, whereas a cold backup, you are completely shutting down the database and copying the files on the operating system level. So in our next nugget, we're going to discuss Recovery Manager and how to actually implement doing those backups. And then in the nugget after that, I'll show you different ways of actually recovering. I hope this has been informative for you, and I'd like to thank you for viewing.